Let us solve a cube resistance problem now. We have a cube having equal resistance. Okay, let us say the resistance is R every time, right? All the resistances are R. Now the question is, there is a cube having equal resistance in its each edge 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So all the 12 edges have equal resistance. Current can enter at any one point. Let us say it is point 1 where the current is entering, and the question says find the equivalent resistance between points 1 and 8. So this is point 1, this is point 8. What is the equivalent resistance between 1 and 8? This is the question. To understand this question, let us first see how the current is divided when it is entering the cube. This is a cube, right? Now understand the division of current. As soon as the current enters at point 1 and it sees three paths. The current can be moving along this path from 1 to 2 or from 1 to 5, 1 to 4. So rather I should say it is getting divided into three parts. Some current flows from 1 to 2, 1 to 5 and 1 to 4. Now that current, since the resistances are equal, so the current value is same. Okay, so at points 2, 5 and at point 4 we have the same potential. Now the current from point 2 sees two paths. It can go to 6, it can go to path 3. From 4 also there are two paths. Current can move to 3 and it can move to 7. From the point 6, 3 and 7 we can see there is only one path which is leading to path 8. 3 to 8 and 7 to 8. Now the current collects and it is coming out of point 1. We have to find equivalent resistance between 1 and point 8. So we are looking at point 1 and point 8. Entering from point 1, division of current, and finally combining at point 8. Okay. So what I have just told you, now I am going to redraw this. Okay. For drawing this, I will take it as point 1. From point 1, I told you there are three paths. So we will draw a resistance 1, 2 and 3. So these are the three paths in which the current can move, and it reaches at point 2, point 5 and 4. So let's label it 2, 5, 4. Right? Now from this point 2, 5, 4, point 6 and point 3. So from point 2 we have point 6 and point 3. Then from point 5 we have 6 and 7. Point 2, 5 we have point 6 and point 7. And from point 4 we have 3 and 7. So there are two paths for the current to move, that is 3 and that is 7. Right? So this is the equivalent circuit I am drawing. First of all, at point 1 it gets divided into three parts, 2, 5 and 4. So that is 2, 5 and 4. And from these points 2, 5 and 4 we have this. Right. Now after point before we move ahead, see, we have 6. That means it is 1 point. We have 3, so it is also 1 point. We have 7, so this is also 1 point. This is 3, this is 6 and this is 7. Right? So now the current moves ahead, and from point 6, 3 and 7 there is just one path. So we will draw one resistance here, one path, and all of them they meet at point 8 and the current goes out. Here the current is entering at point 1. Okay, entering current. here it is moving out. So you can see I have drawn a equivalent circuit of this. Here points 254 are at same potential, 0.63 and 0.7 are at same potential. Okay. So I think I can one more redraw it so that it is still easier for me to solve it. Let me draw it once again. This now again redrawing the equivalent circuit. Okay, the equivalent circuit I am drawing now. Okay, the equivalent circuit looks like this. I'm trying to simplify this to get the resistance value, because we have done series and parallel combination, but to see the series and parallel here is difficult. So we go by symmetry and we use the potential value, where is it same, and see the resistances how they are doing, and we get it. Okay, so they're all connected. Let me connect them. It's not like this, they're all connected. There's no thing which is left out. Now let us redraw this. Redrawing this diagram here. Current enters at point 1. Okay, then it encounters 3 resistance. So let me draw it. 1, 2 and 3. And these 3 resistances are now combining together at one point. This point has same potential, so let us label it as the point 254, having same potential. Okay, here the value of resistance, of course, it is same. Now the current moves ahead and it encounters 6 resistances. So let us draw 6 times 1, 2, 3, 4, 5 and 6, and they all meet at one point. This point has same potential, it is 0.63 and 7. From here we move further and we encounter 3 more resistances. 1, 2 and 3. This point is 0.8 and we have the current going out from here. Okay, so this can be equally drawn into this new form. Now this is a very simple circuit. We can see 3 resistances are in parallel, 6 resistances each of R ohm again in parallel, 3 resistances each of R ohm again in parallel. Okay, the question is find the equivalent resistance between point 1 and 8, and each resistance is given to be R. It's all same. All the resistances are R. Okay, so just for making easy, you can take R to R, any single value. This is the question. Okay, in the given diagram. Now it's easy to solve. See, as the current I, this is the symbol for current. It is not resistance. Current I is flowing in. It reaches at point 1 and we have one equivalent resistance of this. 1 by R, they are in parallel. So 1 by R plus 1 by R plus 1 by R. That makes it 3 upon R. So R equivalent is equal to R by 3. So I will write one resistance having value R upon 3. Similarly, now this point is 254. Now we have 6 resistances. So R equivalent, this was the first R equivalent. Second R equivalent becomes 1, 2, 3, 4, 5, 6. So it is R by 6. Just the way it is R by 3, it is R by 6. Let me draw it. This is R by 6 ohms and it reaches the point 637. Then we have 3. So it is R by 3. Finding the R equivalent. Third R equivalent, that is, this is R by 3 ohms and the current reaches 0.8 and goes out. Now it's a simple series circuit. So the whole equivalent can be found as R by 3, they are in series, and you know in the series the resistances are added. R by 6 plus R by 3. So you solve it. It is 6. So it is 6. 2R plus R plus 2R, that is 5 by 6R. Okay, so we have got our answer. The cubical resistance, the cube which is having same resistance in all the arms, the equivalent resistance is given by 5 by 6R. We have used here the concept that the potential is same at certain points. We have used the symmetry of the cube and we have got the answer.